Ratios of circles. This is a phrase we use to describe all the proportions we can create using what we know about a circle. So whenever we talk about a proportion, we're talking about a part out of a whole. Now, I'm going to get right into all the different parts and all the different holes in a circle, and then we can talk about how to use them appropriately in algebraic situations. So the first one I'm going to refer to is the central angle. So all the central angles in a circle add up to 360 degrees. That's what this image is meant to depict. So all the central angles in a whole circle will always add to 360 degrees. That means this is just a small part of that. Okay, whatever portion that is out of the whole of 360 degrees, which is why we write this ratio this way. Central angle out of 360 degrees is one ratio of a circle. Now let's go to the next ratio, which is sector area. So area we know is how much space an object takes up. And that was the essence of this diagram here, was to show how much space this circle took up over here. If you can't see my arrow, I'm pointing to that guy. And the full area of a circle can be found using pi r squared. So this is just the area formula, right? So this is the area of a circle, and that's the formula. And that can be found on your reference sheet, but I'll say this a lot. Things are only helpful on the reference sheet if you know where they are and how to use them. So knowing that the area of a circle is pi r squared is helpful, but knowing how to use it is even more helpful. So to find this sector area, or the area of the piece of this circle over here, we would need to do sector area over pi r squared. So that piece out of that whole area. Last but not least is arc length. So arc length is a phrase we use to describe a piece of the circumference. So this over here is meant to depict the whole circumference. And this piece over here on the part side is just a little snippet of that. Now circumference is 2 pi r. You'll actually notice on your reference sheet there's two formulas for that, but I always like to use 2 pi r. It's helpful to me just to choose one. And over here is just a small piece of that circumference. So we say arc length over 2 pi r. So let's use some of these ratios to solve a sample problem. Now attached to this video in the description is a piece of paper, or I should say a link to a piece of paper that has all the practice problems on it. This first problem isn't on there, but if you follow me on Instagram, you'll notice that it's there. And in all of these problems, I'm just going to be using these three ratios that we talked about, and I'm going to set them equal at different times depending on what's given and what we are looking for. So those are the three ratios, or three fractions that I can set equal to one another at any given time. So here's my first question. Given the information below, find the length. So length is a big deal because that's telling me I want arc length of minor arc AB. That just means the smaller AB because there's only two letters on this circle, to the nearest tenth of a meter. So they already gave it away. They already told me that they wanted arc length. So I'm just going to write that full ratio out. I know that arc length always going to go over 2 pi r because that's their circumference formula. Now I need another fraction, okay? One of those other two fractions, I need to look at them and see what I have. I hope you already noticed that they gave us this central angle here. That's really helpful, and that often happens a lot. So that means we're going to use central angle over 360 degrees. So let's plug in what was given to us. We know we're looking for arc length, so that's going to be x. And then I'm going to write 2 pi r again, but I actually do know what my radius is, so I'm going to plug that in. 2 pi, and my radius is 2.40. And I'm going to set that equal to, I'm going to stay in the same color this time, my central angle, which is 165 degrees out of 360. Okay, so you'll notice that in all of my videos, I talk about this quite frequently. When I cross multiply, I don't actually multiply in the first turn. This is because it's really important to remember that sometimes we can be distributing. It's not happening here, but it is helpful to keep in mind. So I'm actually going to multiply x times 360. I'm just writing out my multiplication. And this time I'm going to do is 165 times 2 times pi times 2.40. So 165 times 2 pi 2.40. So now this is just an equation that we need to solve. We are going to be solving for x. So I'm just going to highlight x because keep in mind that's what we want. So for that reason, the 360 is on the same side as the x. So I'm going to divide both sides by 360. Now I want to take a moment to talk to you about your calculator because right now I'm ready to plug into my calculator. Over here, I hope you recognize that this is a fraction. And it's really helpful to write it as a fraction because it's really just taking care of order of operations for me. If I keep it as a fraction, my calculator knows exactly what to do. So that button next to the 9 on your calculator is something that you really want to take advantage of because it's going to give you a fraction key. So use that fraction key, use that button, enter that in exactly how you see it with this part on the top and this part on the bottom, and you should end up with x is equal to 6.911503. Now in this particular example, it wanted it to the rounded to the nearest tenth. So I'm going to take a look at this 9 and this 1 is going to tell me if I should round up. That 1 is not big enough to change that 9. So my answer is just 6.9. Also, just another Regents tip. You'll notice I put 6.9. The answer is 6.9 meters, but I am not going to be writing units because if I write units incorrectly on the Regents, they have to deduct points. But if I don't include units because of the way the question is asked, it is fine. So I don't write units. I don't circle my answer. I just write everything right there. I also think it's really important to write your answer unrounded first. So if you make a rounding error, it's quite clear. It's always nice and neat. It's always a good idea to make it as easy as possible for the person grading your paper. Now I'm going to get into those sample questions that are attached in the worksheet. So I love the question we just did because it talks about arc length. A lot of questions when it comes to ratios in a circle talk about sector area. So you'll notice a lot of these upcoming questions are going to be pertaining to that. Excuse me. So let's start with this question from the January 2017 Regents. It's number 21. And I'll tell you right away that this was a multiple choice question. I will show you the answers towards the end, but I find that they can be somewhat distracting, and people often forget that the multiple choice on the geometry Regents is the hardest part of the test. They're multi-step questions. They require a lot of thinking. So it's not a good idea to start looking at those answers until we're really working our way through the problem. So this says in the diagram below of circle O, GO is equal to 8, and the measure of angle GOJ is 60 degrees. They want us to find the area of the shaded region. So this is really misleading because this feels like what I want to find, right? That's my pizza wedge that I always see. But that's not what it's asking for. It wants the shaded region. So this is actually the area that they are hoping for you to find. And that's really important because when we're looking at our ratios, we're probably going to be using central angle. And it's important to note that they didn't give us the central angle here. If I'm using the central angle of the shaded area, this is my central angle. So in order to get that, you'd have to understand that there are 360 degrees in a circle. They gave us the 60. So if I subtract that, I get 300. So this is 300 degrees. Okay, so that's the ratio that they gave me. They gave me my central angle. That's at a 360 degrees. They want me to find the sector area. And the full area of the circle is pi r squared. So I'm going to write that down here as well. So again, I'm going to start plugging in values, but I think it's really important to identify which two ratios you're using and how you're setting them equal. So now my central angle is 300, so it's 300 out of 360 equals the sector area is what I want out of pi. I know my radius is 8 squared. So I'm going to go ahead and cross multiply. I'm going to multiply this 360 times x. And I end up with 360x. So I'm going to write it as x times 360. Doesn't really matter which way you write it. And then this way, I get 300 times pi 8 squared. So 300 times pi 8 squared. And now I just have an algebra problem, right? So it is also important to note that in this problem, it specifically asked, let me back up a little bit, what is the area in terms of pi? So I'm going to show you what that means, or I guess I'll tell you right now. It means that in your answer, there should be a pi. So I'm going to go ahead and show you the answer choices for this particular regions. I don't think I actually have them listed on here to post them, but I do know them. So the first answer choice on this multiple choice question was so I'll just list them for you. So number 1 was 4 pi over 3. Number 2 was 20 pi over 3. Number 3 was 32 pi over 3. And number 4 was 160 pi over 3. So I think that's really important to note because I'm going to have a fraction here. So don't worry about that. Know that that's going to happen. Your calculator will help you create the fraction. Don't be scared. So when I'm solving this over here, I want to get this x by itself. I'm going to divide both sides by 360 degrees. I'm going to put that whole thing into my calculator except pi. When they tell you in terms of pi, you do not enter. So let me just write, do not put in calc. So I'm going to not put that in my calculator. And because I'm not putting in my calculator, it'll be in my answer. I'm going to put my pi right down there. And if you put that into your calculator, and don't put the decimal point so it doesn't round, it should just give you 160 over 3. So it'll give it to you as a fraction unless you ask it to, unless you ask it not to. So that means my answer is number 4. So I just want to point out that there were a couple of different steps here. First, I needed to find my central angle over here. Then I needed to set up my proportion. Then I needed to solve my proportion, right? So this is a complicated multiple choice, which we know, unfortunately, the multiple choice typically are. So just make sure it gives it the work, you give it the work that it deserves. Our next question is from the January 2019 Regents. This is question number 14. This was also a multiple choice question. This one I am not going to give you the answer choices for because it's pretty straightforward, and I think that the other one had a fraction. It made more sense to look at the answers. This one I think you can get. The area of the sector of a circle with a radius measuring 15 centimeters is 75 pi centimeters square. So that's the area of the sector. What is the measure of the central angle that forms the sector? So we already know that they are looking for the central angle. So central angle at a 360, that's what I'm going to be finding, right? So I'll put that there. Then they give us the sector area. So let's put sector area at a pi r squared. So this is a little bit different than the last problem. Same two fractions we're using, but in this case, they want us to find the central angle. So my x is going to go over here. And they're giving us the sector area, the 75 pi. And so I'm going to put that over here. And then for my area formula, I know my radius is 15. Okay, so a little bit different than last time. I'm just going to shift this up to give us some room, but the same ratios. So I'm going to go ahead and cross multiply x times pi 15 squared. So x times pi 15 squared. And then when I cross multiply this way, I get 360 times 75 pi, 360 times 75 pi. So again, I'm just going to notice where x is, and I'm going to get rid of everything that's not x. So pi 15 squared, this whole thing on both sides. I'm going to trust that my calculator can do the order of operations for me. And I have my fraction button, so I don't need to worry. This whole thing is going into my calculator. It doesn't say in terms of pi, and those pi's are going to reduce anyway. So I'm putting it in as a fraction as is. And when I do that, everything reduces really nicely, and I actually get a really pretty number. It's just 120. So that means that the central angle is 120 degrees. But again, I'm just going to put 120. I am not going to circle it. And we're going to go from there. But again, this is a multiple choice, so I would be selecting the correct answer regardless. All right, let's keep on going. This one is a little bit further, meaning it's like you need a little bit more information to get this. This is question number 31, which means that this is not a multiple choice question. So this is worth 2 points, and you really need to know a lot of information to get those 2 points. Let's talk about it. Here it says in the diagram below of circle O, the measure of the inscribed angle ABC is 36 degrees. So they give you this, okay? And the length of OA is 4 inches. That's what you have over here. So that's given to you as well. It wants you to determine and state to the nearest square inch the area of the shaded sector. So you know that you're looking for sector area. So I'm going to put sector area. I told you they love sector area. They use it a lot. Sector area over pi r squared. And you are going to set this equal to something. So they gave you an angle. That's a huge hint that you're probably going to be doing central angle, but we need to find our central angle. This here is an inscribed angle. So you need to use what I call the snow cone trick, which means that the arc is twice that angle. So if that angle is 36 degrees, this arc is 36 degrees. Sorry, 72 degrees. How silly of me. 72 degrees. Okay, so it's twice the angle. The arc is twice the angle. Then this guy in here is our central angle. So that's the pizza slice deal. That is equal. So this is also going to be 72 degrees. So that means that our central angle is what we're going to be using. So central angle, that's out of 360. And let's plug in what we know. We want to find the sector area. That's going to be out of pi r squared. The central angle is 72, and that's out of 360 degrees. I want to point out that they want this to the nearest tenth of a square inch, so that means that there's going to be no pi in our answer. We're going to put this right into a calculator. So if we cross multiply, we end up multiplying x, let me get a bigger highlighter, x times 360, which is I'll do x first, x times 360. And then that is going to be equal to 72 times pi r squared, which is 4 squared. So 72 times pi 4 squared. And now we're going to divide both sides by that 360 because, again, this is my x. I want to get rid of everything that's not x. And again, I say it every time. I know you're probably tired of it by now, but you are going to enter that whole ugly thing into your calculator. You are going to use the fraction button. I feel like that's a little aggressive. The fraction button, and you are going to put it in just like that in fraction form. And you would get your answer to be 10.05309,649. Write down all those beautiful digits. Now we are going to round to the nearest tenth. Is this 5 big enough to change this 0 to a 1? It sure is. So that means our final answer is going to be 10.1. Okay, so beautiful 2 points here. Setting up the correct proportion, getting the correct central angle. I'm sure you can see all the different ways people can make mistakes. In a question like this, it really is each mistake you lose a point. So you really have to be very careful, very tedious, and not make any calculator mistakes, especially if you're doing a question like this. All right, last but not least on this practice. So I want to talk about this question before I go to solve it. This was from the June 2022 Regents. This was question number 24, which means it was multiple choice. I left the answer choices there for you. And this is probably one of the hardest questions on the test. So typically the hardest question on the Regents is multiple choice. The multiple choice questions are just really difficult. So I want to take a moment to star this and say that this is really a challenge question. So if I'm solving this and you're sitting there and you're going, wow, that's really intense, I wouldn't know what to do with this, it's okay. This is the thing that really separates people from getting perfect scores. This isn't the kind of question kids pass on. So if you're one of those that's really striving for that perfect paper, this is something you want to work on. And that's why I'm going to go over it for you. If you're really just struggling to get by, maybe you skip this problem and focus on some others. So it says in the diagram below, of circle O, tangent AB is drawn from the external point B, and secant BCOE and the diameter AOD are drawn. So it's really just describing that image. It says if the measure of angle OBA is 36 degrees and OC is 10, it's my radius, right? What is the area of shaded sector DOE? So I know that I'm going to be doing sector area. I'm actually going to, where am I going to do it? I'm going to write it over here. So sector area, and that's going to be out of pi r squared. And I'll deal with that after. Now, they started giving us angles, so that's a pretty big hint that I'm going to be using central angle. And they do. They really do use that a lot. Central angle with sector area, with arc length, with all of those things, okay? So that's the ratio that I'm going to be using. The problem is I need to know this angle in order to be able to fill that out. So that 36 degrees they gave us is a really big hint. They're using circle properties here, and they want you to know that in order to get that angle of 36, you would have had to have taken the big arc minus the small arc and divided it by 2. So let me just do that over here. It's the big arc minus the small arc divided by 2 is equal to the angle, right? The problem is they don't give us the big arc or the small arc here. They just give us the angle. And this is where things get really tricky. Since this is a diameter, let me make it a little bit bigger. Since this is a diameter, I know that the two arcs have to add to 180 degrees. So if I call this little arc X, that means this big arc over here is 180 minus X. Complicated, right? So if I do the big minus small, it's 180 minus X as my big arc, and then minus X, my small arc, divided by 2, and that equals 36. This is the hard part, people. And if I put that 36 over 1 and cross multiply, I end up with 180 minus 2X equals 72 degrees. And then I can work backwards. I would subtract 180 on both sides. And I end up with negative 2x equals 108. Negative 108, I'm sorry. And then if I divided both sides by negative 2, I end up with x equaling 54. So that means that this arc here is 54 degrees, right? I don't really need to know what that blue arc is, but if you're curious, you can do 180 minus 54, and you would find that that arc is 126 over here. But then I got to still do some angle chasing, right? If this arc is 54 degrees, that means that this central angle is 54 degrees as well, which means that this vertical angle is 54 degrees as well. Crazy, right? So much work just to get that central angle. Now I'm going to plug it in. So now I can go to the second part. They want sector area. I'm going to call that A for area since we already used X in this problem, but you can use X again. Pi, my radius is 10 squared equals 54 is my central angle out of 360 degrees. If I cross multiply, I get A times 360. And if I cross multiply the other way, I get 54 times pi r squared, or pi 10 squared. So 54 times pi 10 squared. And then I'm going to divide both sides by 360. Again, hopefully this is starting to become a little habitual to you now. And then when I enter that in, I'm going to notice that all of my answers are in terms of pi. So I'm going to leave it as A equals, and I'm not going to put pi into my calculator, right? I'm going to put everything else into my calculator because pi is going to be in my solution or in my answer. And when I do that, I end up getting 15. So I end up with 15 pi as my answer. And if I take a look back, it is here. That's option number 4. So listen, I'm not going to lie to you. This is crazy. This is so hard, right? Even just knowing to do the x and the 180 minus x, this is a really complicated problem. So just do the very best you can, and please don't get discouraged if you get something this hard on the Regents, because the Regents is just hard. There's some really difficult questions there. It doesn't say anything about you to have trouble with them. Just do the very best you can and don't give up, right? 3 hours is a long time. Make sure you're doing it all. So again, we just did a lot of practice problems, which I love, that used a lot of sector area. But I want to remind you, there are 3 separate ratios you can use, and you can set any one equal. So the big keyword in, I need to get my purple highlighter because I'm crazy and I need to color code, right? But the big, and I didn't get it anyway. The big keyword in arc length is length. So if you see the word length, you're doing arc length. If you see the word area, you're doing sector area. And central angle, I think, will be a little bit more obvious to you. Make sure you pick the right 2 ratios. Any 2 ratios you can get, set them equal, and solve. Ratios in a circle are becoming really popular, so thank you for watching this video. Check back at the channel for more videos on all Regents topics, and check Instagram for cold, hard, quick facts.